Hello, my name is Vladimir, and today I have this pleasure to introduce you our UVENT-T-S ventilator. This is compact size expert class machine which is intended for intensive care, invasive and non-invasive ventilation in the hospital, for in-hospital transportation, and also in ambulance. The device is designed for all ages of patients, for neonatal, pediatric, and adults. It has a tidal volume range starts from 2 ml up to 4 liters. It's desired for invasive and non-invasive ventilation. We have a possibility to select the type of invasive interface, endotracheal or tracheostomic with its size, and non-invasive interfaces with a mask, with a helmet, and high-flow oxygen therapy. According to a clinical case, doctor can preset the ventilator to provide a proper respiratory support for the patients. And the device has a possibility to provide a full range of mechanical, interactive, spontaneous modes, intelligent ventilation, advent and provent, and specific ventilation modes like a cardiopulmonary resuscitation. All of these modes are available in basic set. Beside of the full range of ventilation modes, all the devices are coming full-featured, no software options, no hardware options. The device equipped in basic set with the CO2 and SpO2 channels, the pneumatic nebulizer, and also auxiliary monitoring channel with the balloon catheter, esophageal balloon catheter pressure monitoring, and it has built-in turbine and ultrasonic oxygen sensor, which is maintenance-free, calibration-free, lifetime warranty. So to set up the device is very easy as ABC. We select the patient, we select the connection, and we select the mode, and then start the ventilation accordingly. Actually, here we have set up for helmet, so I will select the helmet ventilation. So the system will give you a notice about the circuit assembly diagram, and we have a possibility to select 3 modes in the helmet ventilation. So I will select pressure control, pressure support. We don't have oxygen at the moment. So now the ventilator is ready to set the ventilation. During the ventilation process, device demonstrates us curves, digital data, and settings buttons that customer can adjust, customize according to his needs. Device has a possibility to freeze curves, to make the measurements of all of the parameters, and also to have a direct access to main parameters, and also open the additional parameters for setup. Especially for helmet ventilation, we have a possibility to adjust the base flow, which is crucially important for patients with the CO2 rebreathing issue, and therefore in our ventilators we have a base flow adjustment as important settings if to compare with other machines where base flow is fixed on a certain level. Beside of the all ventilation modes, we have a possibility to customize the view, to customize number of curves, to add some trends on the home screen. We can select any of trend, and to get it high resolution on the same screen, we have widgets with a lung, dynamic lung widget. We have a possibility to add loops. We have possibility to add energy expenditures, metabolic monitoring, and also some graphs according to our needs, according to clinical situation. The part of digital parameters are easy to be customized. If you need any parameter, you just drag and drop it to the home screen and then save it under the user profile, so it will be possible to recall it while you come to the shift again. We have a possibility to switch to big numbers, especially during transportation, or in case if distance view is most important, we have a possibility to set it up in this way and provide such a kind of visualization. We have possibility to make a screenshot, records, shortcuts to alarm settings is also available over here, as well as silencing. All the features and with a user-friendly interface and very understood, easy to use, and reliable for nurses and the respiratory therapists, we have a possibility to manage the different types of visualization. We have a possibility to make the manual maneuvers like inspiratory hold, expiratory hold, oxygenation. We have access to menu of settings to analyze the trends for 72 hours, to perform the maneuvers available for each clinical case. And as well, we have a possibility to select different modes. For helmet ventilation, we have 3 modes only. For other connections, the number of modes is dynamic and can be changed accordingly. Beside of the connection type, from this part we have a connections interfaces for the electricity, for the oxygen connection. Here we have both of the connections, like a high pressure or low pressure connection of the oxygen, and USB HDMI interfaces. With the USB you can export data. For HDMI we can connect the external screen, and Ethernet for hospital information system connection with a HIS integration. The USB Type-C is used for service purpose, for remote diagnostic procedure during the maintenance process. Device is equipped with the standard VESA mounting plate. Pardon? With the standard VESA mounting plate, which is suitable for different mounting solutions and can be mounted on the trolley, on the wall mount, on the ambulance mount, or even the stretchers. That's the universal mounting solution available in these ventilators. So this is compact size, expert class machine with all necessary tools, ventilation modes for all range of patients and for any clinical case. And now I will explain you a few points regarding the ventilation modes that we have: intelligent ventilation, Advent and ProVent. So the Advent mode is totally equal to adaptive support ventilation, ASV, with the automatic management of minute volume percentage that's adjusted by the doctor, and then the system automatically manage inspiratory pressure, IU ratio, and breath rate accordingly to the breathing mechanics of patient, and maintain the minute volume in automatic way. So breath by breath adaptation is used for the Advent ventilation, the same like a ASV, but here I would like to point out that ProVent, it's the similar mode to adaptive support ventilation, but it has next generation of interaction algorithm. While the patient is starting to breathe spontaneously, the ventilator is acting in the way that patient, while patient is breathing spontaneously, there is an in-breath synchronization. That means if patient have if patient have a spontaneous activity, the ventilator is synchronized with the patient and provide the necessary support, only those portion which is necessary to achieve desired tidal volume. And if patient has the spontaneous activity, the strong spontaneous activity, the ventilator will manage the flow support according to patient needs, like here, with allowing patient to realize his spontaneous breathing pattern without increasing airway pressure too much. So if we will change the layout a little bit, I will increase the speed for the curves. So here I will demonstrate you the action of ProVent mode with a spontaneous active patient with a weak effort, strong and strong effort. So for the weak effort, now we have mandatory one, and then weak effort of patient. So here you can see that patient made a weak effort, ventilator supported him with the flow, but then the rest part has been made by the mandatory ventilation, and the patient got the necessary tidal volume. And as now I will simulate the strong effort. So that was the strong effort. Patient took higher tidal volume, but the airway pressure, mean airway pressure, was not that way dramatically increased during this kind of cycle, and that's the key point that ProVent has more intellectual algorithms in interaction with the patient, taking into account the assurance of desired tidal volume and providing the proportional support in terms of work of breathing during the weaning process. And we have one specific ventilation modes like a cardiopulmonary resuscitation in case if a heart attack happens, the doctor can simply activate with a two press the CPR mode while the ventilator will be switched to 100% of oxygen with a BiPAP algorithm, and then doctor can start with the chest compressions. The ventilator recognizes chest compressions and then will guide doctor about the frequency, will give the idea about the airway pressure, about the compressions efficiency, and as soon as we have CO2 sensor connected, you will get a feedback with the CO2 trend as the main parameter for spontaneous circulation establishment. And as soon as our CPR is finished, we can switch back to previous ventilation mode and proceed with the respiratory support for a patient. So the CPR is just helpful to handle the critical situation for a patient, and only one clinician will be capable to provide a full range of cardiopulmonary resuscitation. Ventilator will cover ventilation part, and the doctor will cover the chest compressions in order to establish spontaneous circulation.